Minesweeper. So this question is the Minesweeper game. So it has a Wikipedia page on how does Minesweeper works. The description of this problem is very verbose. Basically, it's talking about using an M to represent an unrevealed mine, and then E represent a empty square, right? And numbers will be like how many mines around the cell, and X will be a revealed mine. Okay, try to ask us, like by given a current board of the Minesweeper game, if we click one of the cells, what is going to be the next state of the board? So this is what it is asking for. So for example, the input of the board is all empty, like unrevealed cells, except a unrevealed mine. So this is like a beginning state of the game. We have only one mine in here. So by clicking 3-0, so click here, the next state of the game, of the board, is going to be like this. So empty cell will be actually revealed recursively, and then like this mine will still remaining unrevealed, and all the numbers revealed except this the cell over here. Okay, so an example 2 is we further click the mine. So when we click the mine, then it will show an X instead of M, because X is denotes a revealed mine. Right. So this is a statement of the problem. So let's take a look at the example in here. So we have the original board. Suppose we are inputted with this, like a bunch of empty, unrevealed squares, and we have two mines in here. Right. So this is also a beginning stage of the board. So keep in mind that our input can contains like a board that already being played. It doesn't have to be in the initial stage. It might be like numbers in here already. So the entire problem is asking us to return the next state of the board after the player click one of the cells. All right. So by looking at this board, so like how do we figure out what is the next state of the board when a person click, right? So intuitively, when person click this cell, for example, so we can have a pre-calculated board. Like everything, for example, like everything is already reviewed. We can call it reviewed board in here. And then when a person, for example, click this cell, we just review this cell and then return the board. For example, like we're going to return this, right? So as long as we have a pre-calculated, pre-reviewed board, then when a person click, we can consult to the this board, reviewed board, to figure out what are we going to return for the next state, right? So how about like the person not click a number? So the previous example is click a number. We're gonna just return the number. How about they click a mine? So if they click the mine, then we're also gonna return what's in the revealed board, because we already pre-calculated this is converted to X instead of M, right? All right. So the next question is when a person click a cell that has no surrounding mines, which denotes 0 in the revealed board. Right, what are we gonna do? So for example, we click this one, and then it's not enough for us to only return 0 here, right? So we're gonna recursively return, if it's 0, we're gonna recursively return the cells adjacent to it. For example, this one, and this one. So by mimicking, this is like simulation, we click this one, and it's 0, and we're gonna click 1, 2, 3, which is all adjacent cells compared to the original cell, right? So when we click 1, we're gonna stop here because that's a number. We're gonna just update the board and then review only 1 in here. Similar for this number. And we see a 0 again, we're going to also reveal this, right? Again, so we're going to reveal this, and then which in turn reveal this and reveal this, etc., etc. So that's where we can achieve the requirement that if it's an empty cell, revealed empty cell, we're going to recursively open the board for them, right? Yep. Okay. By knowing this, okay, so we need a reveal board. So how do we calculate the reveal board, right? So it turns out that all we need to do is trying to figure out the real board based on the mines in the original board itself. So for example, in this case, right, we have a bunch of like undetermined, undefined cells. We don't know what numbers or to fill them in. But then like after we iterate through the mines, we know by definition that if we have a mine, the surrounding cells for this mine is going to be incremented by 1. So we see a mine here, we know these numbers is at least 1, right? And if we keep going until we find another mine, and for this mine, surrounding cells for this mine will be original number plus this mine, plus 1, right? So that's why in the revealed world, we're going to see, okay, so we have 1, 1, 1 in here, we have 1, all 1s in here, and then when we see this mine, we're going to increment the 1 to 2, and then so as this one, okay? So after we iterate through all the mines, we're going to have a calculated reveal board, right? And the rest, like if it's numbered, then we already know it's number. If it's 0, it haven't been override, then we know those are empty cells, right? Okay, so by knowing that, let's take a look at the code. All right, so first we have initialized a revealed board, which is the same size of the original board, and we iterate through this original board, and then initialize the reveal board to all zeros. There's no mines, so that like every cell will be 0. And if there is a mine, then we're gonna override it to an x instead of an m. Okay. So after we have our mines in place, we're gonna iterate through all the mines. And when we see a mine, we have the ij position, right? When we see a mine, we're gonna iterate through all the surrounding cells. I mean, 3 by 3 surrounding cells like this. And this is for two for loops. It's actually including the cell itself, but it doesn't really matter. So we iterate through these 9 different cells, and then we do an add count operation. So what does add count do with the position? So basically, like we know that we're gonna add count if it's a number, we're gonna add 1 here. No doubt about it. So, but if it's a mine already, then we don't do anything, right? So if like somehow it is off board, right? The coordinate is off board, like somewhere here, then we don't do anything. So add count will basically calculate the mine and then augment the surrounding cells with 1, right? So once we've done this operation, then we have our revealed board being initialized correctly. So this is the board, this is the final state of the game, right? Everything is being revealed. Okay, now after we have the revealed board, we're going to simulate the user click. So the click method will pass the position, row and column, and then the initial board as well as the revealed board. All right, let's take a look at the implementation. So this one also, like if it is off board, then we're going to return without doing anything. So, but on the other hand, if we click the cell, the user click the cell is not an unrevealed mine or unrevealed cell, right? He or she just clicked a number or a revealed one already, something already been calculated, then we directly return because we know that things has been already calculated, right? Yeah. So other than that, like we're gonna assign a reveal variable in here. So no matter what's the value of the revealed board, we assign to it, right? So if this is just doing transformation because the final example wants us to show that the empty cell, revealed empty cell as blank B rather than 0. So okay, we do a transformation here. Say if it's 0, then we return a B, right? And after that, we're gonna reveal the cell for the original board, right? No matter whatever we clicked, right? Because it's unrevealed before. And now we're gonna further check if this is 0, if the cell is actually 0. This is meaning that hey, we click the cell that has no surrounding mines. So because of that, we are talking about before, we're gonna recursively click each cell adjacent to it. Okay, how do we do that? We do the same thing. We're looping over through the 3 by 3 square, and then we do a click. We do the same thing. We click it, and it goes back to the another iteration of the recursion, so that it tries to do the same thing. If you click it itself, then it's already revealed, so it doesn't actually go through the looping again. So once we've done all that from the click, then we're going to return the current board because we already override the results. So this will be our next move, next state of the game.